Okay, good morning. Good morning, everyone. Welcome to, Beginnings Peering Forum. This morning session it's a tutorial that we are conducting at APNIC. It's called Routing Registry Function Automation using RPKI and RPSL. So before I begin this session, just a quick check. How many of you are familiar with RPSL? Have you used RPSL before? How about RPKI? A little bit, maybe have heard about it. Whenever APNIC goes to attend a meeting, a conference, these are some of the topics that we try to convey to the members. It's very important, and you will see as we proceed with this tutorial why that is the case. Now, stepping back a little bit, how many are familiar with routing protocols? Yes? How many are maybe doing some filtering with their routing? Most of you. All right, so this is the right crowd. Very good. So I just wanted to check that because it's important. It's a technical topic. Okay, so knowledge of internet routing is important coming into this session. I don't want to take a lot of time trying to go through the basics. So if you're familiar with BGP, then we will have an easy time going through this session. Next, have an idea about routing policies, some familiarity perhaps on Internet Routing Registry Database, IRR. If not, that's fine. That's why we're here, to learn more about it. This is particularly about securing routing. So some people that would come in this session would ask, do I need to know about crypto? The answer is no. It's not necessary. However, some understanding of the generic principles of public key infrastructure, or PKI, is very important. Okay? So what are we going to discuss? We have a very limited time, 1.5 hours to cover all of these. Actually, the slides that I'm sharing with you will probably be enough to cover for half a day. I did that so that you have something that you can look at, a reference for you on how to implement things on your own time. But forgive me if I will pass through some of the slides quickly. Okay, if we already know most of those like basic stuff, right? So what are we gonna cover for the next hour and a half? We will start, of course, with just the foundations to get everything in order, BGP 101, looking at different routing policies and all that. And then we will go to the core of our discussion, which is RPSL. Okay, that's the first part. So we'll look at how to create RPSL objects. What are those different types of objects? How can you implement routing policies using these RPSL objects? What is Internet Routing Registry? What's the difference between IRR and the WHOIS database? Okay, how can you create those objects and how are they added into the IRR? Now, the second half of this session is all about RPKI. Now, as I've said, both of these topics, okay, will cover the larger, I would say, issue on securing your routing. Okay, now, BGP 101, very, very simple. We have here a diagram that talks about, well, essentially announcing a prefix and how it's received by other routers in the network. So here you have two networks, AS6551 and AS65549. If I need to send packets, if I need to send traffic going to 65549, right, coming from this network, so maybe the prefix is 2001 DB8::1. How does that work? Very simple. You need a layer. Well, basically, that's what the routing protocol would do, wherein this network here will learn about this network prefix, right? Through that announcement, I know I have an entry in my database, okay, or we call it more commonly as routing table. In my routing table, I'll have this prefix going to this /32 block, and how to get there. My AS path. This is my AS path, right? How do I get to 2001 DB8/32? I have to hop through two networks, 6550 and 65549. Right? So that one is very clear. That's a very easy concept. Now what about if I have another network, let's say AS65536, and he also announced the same prefix. You notice in this case, we have two different networks. Okay? Two very different networks that are announcing the same prefix. And I learned both of them. Now from my router here, I have another N3 going to this block. Okay? If I'm announcing a more specific prefix here, maybe a /48, not a /32, where will my traffic go? It will definitely go via this path. So I will hop via 6551 to 6550, and then 65536, ignoring this router because this is now a longest match route. Right? So is this a problem? Well, maybe there are cases that are not. But what if, okay, I am, this router, okay, owns this IP address. He is the one who's supposed to actually announce it. And this one, maybe through, I don't know, maybe it's not a malicious intent, but maybe just some mistake that he was able to announce it. What happens? Traffic goes his way. Right? So this one is basically how to calculate the best path, how do you get from your source to your destination, how does your router compute, how to get there. You look at many different factors, right, such as AS path, which one has the highest weight, local preferences, AS path, MED. Those are particularly BGP attributes that you can kind of like manipulate. Okay, you or your neighbors can set or change those attributes so that it can have an impact on how your traffic will flow. If you want your traffic to get out from your upstream A over upstream B, you can do that by manipulating your BGP attributes. If you want incoming traffic to get to your network from your provider B over provider A, you can also do that. Now, if going through the same example, okay, one has the longest match route, meaning it will have a preference. Now, this has an impact on how traffic flows internet-wise. Correct? So, constructing the forwarding table, very easy. So you have here, through your routing protocol, you learn about different routes via BGP, through BGP in process. Some of those are accepted, some are discarded. Now that's a very important concept. Why? Because BGP as a routing protocol is used, and it's very, very useful in controlling your traffic by filtering. You allow traffic that is basically maybe based on your own policies in your company, in your organizations. You can prefer which traffic you're allowing in or which traffic you are sending out. Okay? So by implementing that through BGP, you accept some of the routes that you have learned from your neighbors, and you discard some of those routes. Not everything is accepted. Now, out of that, you have your BGP table. It goes to the routing table. The routing table contains all the possible routes, not just learned via BGP, but maybe learned via OSPF, through other routing protocols, through connected routes, and all that. And the best path among those all possible routes goes to your forwarding table. Now, going back to BGP here, you have a BGP out process. The best path will be announced to this BGP router's neighbors. Right? Very easy concept. So two main planes here. You have your control plane and the forwarding plane. In the control plane, you have your routing table there. The routing protocols are working. You learn about all those routes through your peers or your neighbors. Now, this other part is your forwarding plane. Okay? This one controls, in a lot of ways, it controls how this works. Your forwarding table is actually how you forward the packets, but it depends a lot on the information that you got from your control plane. Okay? Now, this one, essentially looks at looking at routing, looking at BGP, and the whole BGP process. What can we observe? Okay, what can we get out of learning how BGP works? We know that you learn about different routes from your peers. You have connections to, say, an IXP. You have direct connectivity to another network, perhaps. Okay, peer-to-peer connections. You have all these sorts of places where you can learn about how to get to other networks. Okay, but is there security there? BGP is a very trustful protocol. Okay, learning about these routes is basically what you get from your peers. How do I now check whether they should announce or they are the rightful organization to actually announce those prefixes or those blocks? How many of you have got your own IP prefixes? I'm sure many of you, right? So you announce them to the internet. Now, how sure are you that no one else, no other network on the internet has announced or is currently announcing your prefix? As you know, with routing, it can be local, okay? I might see a very different route as compared to what you see on the other side of the globe. So those are some of the issues that we can see. Routing incidents can happen anytime. And with incidents, we mean misconfigurations, whether it's malicious in intent or not. I would say, for the sake of positivity, let's call this as misorigination. Someone, through fat finger, mistakenly typed in his configuration and mistakenly announced someone else's IP address block. If you look at it in the malicious way, maybe we can call it as prefix hijacking. There's an intent to it. There's a negative intent. Historically, this has happened a lot of times. Here, you can see just, a few of them, really, some of the big major events that have happened. This one, in February 2008, by YouTube, is very popular. It is actually one of the triggers when a lot of people in the community started pushing RPKI. What happened here? YouTube access has been somehow blocked in Pakistan, and instead of you going to YouTube to see cat videos, you will go to a page that is owned by Pakistan Telecom, which doesn't give you anything because it's timing out. Because we're basically, all traffic is going that way. Okay? So it was in the news because it's a big company. It's Google, it's YouTube. Now, there are other incidents. In Brazil, it's happened. China Telecom. In our region, it's happened in Malaysia, in Indonesia, and a few other countries. Now, I'm not saying that it only happens 5, 10, or 100 times. I would say that every day, this is actually very possible. It happens. So what do we do to prevent this? What do we do to provide some sort of, say, security with the prefixes that we announce, the prefixes that we route? Two things. Here, to secure internet routing, we need to do a couple of things. Okay, some of them are done manually, administratively. First one here is we must be sure that a network is only announced or originated, a prefix should only be originated by this particular network. If you are assigned an IP address block, your network, and only your network should announce that prefix. Okay? But very big question there. How do you actually verify? How do we check? Is there a way to know this? Okay, how do we make sure that false advertisements does not happen? How do we avoid that from happening? Okay, there are checks that we can do, okay? But we have to be vigilant in looking at that. Another one, a transit network should filter customer prefixes. Now this first block here is mostly for those who own their IP addresses. This block on this right side is for those transit providers who are allowing customers or end users, okay, to pass through their network. So in a way, they are announcing or forwarding the blocks that are announced by these end users, right? So question there, or what should you do there? You have to always check that the customer prefixes and ASN delegations are correct. Okay? At the end of it, it's still about trust. There's transitive trust. If your customer says that, yes, that's our block, do you just trust that? Or do you perform some verification checks? Or do you actually block them at all? There are a few incidents that have happened over the past couple of years where the transit provider, maybe out of just neglect, okay, just open it up. No filters whatsoever. So if there is a misorigination on the customer side, it is then propagated everywhere, okay, from that transit provider to its upstreams and everywhere, affecting how traffic flows. Okay, so you have to do your part if you are the owner of the IP and if you are a transit provider, if you are allowing customers, okay, to forward traffic or to pass traffic onto you. So what should we do? This is talking all about policies, creating routing policies. What types of traffic to filter out, what types of prefixes or announces should be allowed in or not, both ingress and egress. So here, in the next few slides, we will be talking a lot about routing policies. What is a routing policy? How many of you have a routing policy? Everyone, right? Who doesn't have a routing policy? Okay, policy essentially, like your routing policy, depends on your organization's policy, right? What's allowed in my network, what's not allowed, and things like that. So a routing policy essentially is a kind of like a description of your own organization's policy, okay? And how you say, what are your relationships with other networks, with your peers, with other external BGP networks, right? So if you have one, two, or many different peers, okay, which sorts of prefixes are you announcing to them? Which sorts of traffic are you allowing into your network? Now, in some cases, this can also describe internal BGP relationships, but we'll not go into that. I think we will stick with external BGP relationships with other networks. Now, your routing policy, okay, do you just keep it to yourself? Do you just implement that? Well, it's up to you, but there is a mechanism, okay? There is a public database. We call it as the IRR. How many of you have heard that before? Internet Routing Registry, okay? There are many IRRs available, okay? The regional internet registries, such as APNIC, maintain an IRR database. There are others as well. Most commonly, I think, if you've heard about RADB, okay? RADB is an example of an internet routing registry. There are many others. You can have a look. There's a link. There's a website that lists down all of the, well, most of the available routing registries out there. So more about routing policy. What's contained in the policy? What exactly? Basically, it's an information that will be added into the public database that describes your network, describes your BGP peers, along with your routes. Which routes are originated by a certain peer, okay, which are imported or allowed coming from this particular peer, which are exported going into that peer, okay? And if you have multiple possible routes, what do I prefer? Based on my policy, where should I go? Should I go to link A, link B, link C, etc.? Okay? And how can we influence that? By creating our own routing policy. Does that make sense? Okay? Here, I have just, say some case, I have actually a different slide that discusses this in more detail. But once you have received routes, okay, once you receive prefixes, how do you forward them? Okay, how do you act on them? We have here 3 different options or cases. One is, well, depending on which prefixes you're getting from your customer. Is your customer single-homed or multi-homed? Is your customer announcing a non-portable prefix or a portable IP address block? There is such a thing called as LOA check. Have you heard of that? That's legitimacy of address. If your customer tells you, comes to you, you're the transit provider, and asks you, hey, can you please announce this prefix? This is our IP address block. Can you announce it as coming from this AS number? What do? What are the verification checks that you do? LOA check is the main one. Again, it's a manual process, but through the Whois database, okay, you can see whether that customer is supposed to actually announce that prefix or not. You've heard about the Whois database, right? If not, there is a link on the APNIC website. We're actually going to look into that as related to IRR just a little later on. But you can check the Whois database to see whether this block belongs to this network, okay? And also, what is the status? Is it portable? Is it allocated? Is it assigned block? Depending on that, then you can decide how to forward that traffic or that announcement, okay? Now, why define a routing policy? What do you think? One of the reasons is for documentation, okay? Again, it's a description of your network. It's a description of your policy. Or I would say your routing policy restrictions or constraints, okay? Those constraints will be added into a publicly maintained database, okay? Kind of like a documentation of your own network so that others will learn about it. Provides routing security because you are now providing other networks the opportunity to see, okay, that this should be announced by this network and things like that. Basically, look into what should be announced coming from this prefix, and then they can create their own policies accordingly, okay? Can peers originate this route? Can peers act on this particular route? Can they transit this particular route? Because of that public database, they can see that. They can see that information. It also allows for automatic generation of router configuration. This one might be more suited for us here. I think most of you in this room are engineers, and you like automation. Now, we do a lot of like manual things in securing routing, but to automate this or to say have a configuration ready to be imported in your routers based on the output of the IRR, okay? Do you think that's possible? How many of you have done that? Okay? There are ways to do that here, but that obviously is based on the information that we are getting. Meaning, in your case, for your network, make sure that the information that you have on the IRR are all correct. Okay? Okay? It's a combined effort from everyone that's involved, which is essentially all of the networks out there. Okay? It also provides a debugging aid for us. If you're like troubleshooting, what's wrong, what happened, how come my traffic is not getting into that destination, maybe it has got to do with a certain network's policy. Maybe one of your transit providers is not allowing it. And you can somehow see that, okay, by looking at their policies here. Okay, let's divide this into 2. When we talk about securing your internet routes, we are looking at 2 like models on how this is done. One has been there for a while. It's well established. Okay, there are standards for that since I think 1995 or 1998, and many people, many networks are using it. Okay, so if you are familiar with this working group in IETF. It's Routing Policy System, or RPS working group. They are the working group behind RPSL. The other one on this side is SIDR, Secure Inter-Domain Routing Working Group, also in IETF. Now, they are the working group behind PKI, Public Key Infrastructure, and later on, RPKI, and maybe once it's available, BGP-SEC. Okay, so the goal is kind of similar. Okay, the goal is to secure routing here by looking at routing protocols such as BGP and how you can add or use public key infrastructure for that. The other one is coming up with a language, a specifications language that describes all of your routing policies and adding them into a public database so that everyone can see it. So that's the gist of what we are going to talk about today. We'll look at the first one, okay, and then proceed with the next one if time permits. So RPSL and Internet Routing Registry. What is RPSL? How many of you have created an object in the WHOIS database, a route object or an autonome object? No one? I guess we'll have to review that a little bit. Very quickly, we'll look at those different types of objects. But what is RPSL? RPSL stands for Routing Policy Specification Language. It's object-oriented, meaning to define something, you are creating different types of objects. Things like route object, autonomous system, okay, INET-num or INET6-num objects, route objects, AS set, route set. So if you've heard about those things, those are parts and components of Internet Routing Registry, and you create them, okay, or you make them using RPSL. You have information there that, let's say, fields there that is basically what RPSL would look like. It describes things like prefixes, AS numbers, different BGP peers, and the management responsibility. Let's look at some examples in a while, right? But very quickly, RPSL is actually a replacement of RIPE81. RIPE81 is a previous, let's say, kind of like language that's used for this particular purpose. And then later on, RIPE181. But as we can see, there were limitations doing that. There are, say, policies that cannot just be implemented using RIPE81 and RIPE181. That's why we have RPSL. If you want to read more about it, these are the RFCs. Particularly, I would say have a look at RFC 2622 and 2650. I don't have RPSL NG here. I think it's 46. I'll have a quick look later on which RFC, but that one is for IPv6. So how to use RPSL, the language, in RFC 2622, and some really good examples on how you can create, say, or use RPSL in practice in RFC 2650. Okay, this is an example of an RPSL object. If you are familiar with WHOIS database, well, there's not much difference because IRR is actually, can be considered as a subset of the WHOIS database. So a lot of like the formats and attributes are very similar. Here is an example of a role object. Okay, on the left side, you'll find attribute names. These are different fields, and the information or value for that particular attribute. This whole thing is what we call as an object. Now, to have a look at all of those objects, I will not go through each of them, but to have a list of all of those attributes and types, have a look at RFC 2622. In this session, we'll look at some of the objects that are important for our particular purpose. As I've said, okay, I do get this confusion every once in a while. Like, so what is IRR? So what's the difference between IRR and the WHOIS database? So is it a different database? If I want to update, which one do I update? Does it automatically sync? Things like that. Okay? To simplify things, look at the bigger picture. You have here the WHOIS database. each of the RIRs. You're familiar with an RIR, right? RIR, Regional Internet Registry. APNIC is one of them. There are 5 regional internet registries around the world, and each of us maintain a WHOIS database for the objects, for the resources that we are distributing. IP addresses, AS numbers, we have them maintained in the WHOIS database. Now, inside or part of the WHOIS database, you have the RIR. The IRR. The IRR pertains to objects that are related to routing, peering, peers, and routing policy. Clear enough? All right. Okay. These are some of the objects that you will see in the APNIC database. The things that are possibly most important to us, well, it's most of these really, but let's group them together. The first 3, first 2, person, object, and role object. Those are objects that pertain to contacts, contact information. If I have, say, an entry about a particular resource, an IP address or an AS number, these are the contact people for that resource. If I have any issues with that, if I have any questions for that resource, I should contact this person object or this role object. Okay, those are your contact information. Next one here, the next 3, INET-NUM, INET6-NUM, and AUTH-NUM objects. Those are the resource objects. Once you have your own resource, say APNIC has delegated a /32 IPv6 block to you, then an object for that, an INET6-NUM object will be created for that. Okay, if you have an IPv4 address, same thing. Okay, there will be an INET-NUM object that you can find in the WHOIS object pertaining to that. Okay, next, you also have here, okay, this one I suppose will be very important for us for the IRR, route object and route 6 object. Okay, if you have a prefix and you want that prefix announced, okay, coming from, say, an AS number, you can specify that using a route or a route 6 object, depending if it's v4 or v6. Next, you have here a maintainer object. Okay, for all of these different types of objects, okay, everyone can see it. It's a public database, but only the maintainer can make changes to that object. So if you have an IP block and there's an object for that block, then you should possibly have the maintainer password for that. Okay? I'll explain that a little bit more, and we have some examples going forward. But if you have questions, please feel free to ask them now. I'll go through quickly on some of the objects and some examples. To have a complete list of these attributes and what values you can put in there, you can check the APNIC website. You can also see there if it's a key value, if it's a primary, look up key value, if it's mandatory or optional fields. Some examples. This is an example of a person or a role object. I think what we have here is a person object. So it's a typical description of a person, right? He has a name, he's got an address, country, phone number, fax number, email, and things like that. You also have a maintainer, and this is very important. And this one, a nick handle, is a unique value that defines that particular object. We can reference, we can link these different objects together. So to link to a person object, we will use this nick handle. Example of an INET6-NUM object is this. This is the /32 block for APNIC training. Okay, so that's your main key value there, net name, description, country, and you have their administrative contact and technical contacts. Again, if I have any questions and issues for this prefix, say I notice that I'm receiving a lot of spam coming from this IP address, or maybe they're announcing that block, they're not supposed to do that, then I can contact these administrative or technical contacts. If you notice there's also a main object, different types of maintainers. Main by, main lower, and main routes. Just think for yourself for now. I have an example that shows you what the differences of them are. But think by yourselves for now, what is the purpose of having these different maintainers? What do you think? So what is a maintainer again? Okay, it's used for authentication. If I want to change any information, say in my person object here, maybe my address has changed. Who can change that? The one with the password for this maintainer, main SG ABC Internet. If I want to change information, maybe the administrative and technical contacts for this INET 6 now must change. Who can change that? The one who has the password for this. Basically, it's coming from, this is delegated from the APNIC hostmasters. That's why your main by there is APNIC HM. But any further delegation for this block, okay, can be changed by this maintainer, mains AU APNIC training. Clear enough? That's an example of a maintainer object, by the way. All the other fields are really very similar, right? You have administrative contact, technical contacts, who's the other maintainer for this, who's changed it, who's updated it. But it's a very important object because it is referenced by all the other objects that you create. So, hierarchical authorization. So you've seen those three types, main by, main lower, and main routes. What are the differences between them? In most of the objects, you might just see a main by, okay, field. Maybe not all the others, okay? But if it's a block that's been delegated to you and then can be further delegated to your customer, maybe it's an allocated block, then it's possible to have a main lower attribute. So what's the difference between the two of them? A main by, well, main lower as well, is used to protect any object. Okay? Any changes to this protected object must satisfy, of course, the authentication. So if you have a main by for that object, only that person can change it. Only the person with a password can change it. How about main lower? Anything that's related to sub-assignments. So as an example, we have our /32 block. From that /32, you want to subdivide them and distribute to your customers. Maybe give them each a /48. So for this smaller delegations, okay, the main lower is, of course, you. You can create them, you can change them, you can manipulate them yourselves. Okay, so that is main lower for any subsequent allocation or customer assignments for that block. What about main routes? Now, if you are going to create either a route or a Route 6 object, you can only do that if, okay, for these four objects, like INET 9, INET 6 num, or OTNUM objects that are using that particular main route maintainer. Okay, so they have to link together. Okay, they should be maintained by the same main route field, main route object. Okay, probably have an example here. So here, I have this block. This entire block is one allocated to APNIC from IANA. As you know, IANA maintains the entire pool, right? From IANA, APNIC has been given or delegated a /8 block. From that /8, we delegated a /22 to an APNIC member. And then from that /22, it's been, okay, chopped some more. And we've given say /23, /24, or /26 to customer as a customer assignment or sub-allocation. So who's our maintainer here? The block, this particular big block here, who's the maintainer? APNIC or IANA? Well, the answer is over there. It's IANA, because that block has been allocated to APNIC from IANA. What about this block? Going to the APNIC member. The /22 block is maintained by APNIC. So you most likely will see made by APNIC-HM or APNIC hostmasters. Okay? What about this sub-allocations and assignments? The made by will be U. Okay, if that's your block, then the main type will be U. Okay? Okay. You can skip that. It's explained. Another object. And now we're moving into some of the objects that are important in IRR. Route and Route 6 objects are one of them. Okay, this is an example of a Route 6 object. What you can see there. Route 6 object, you have this /32 block and the corresponding AS number that should announce that prefix. Now we're going somewhere. So you have a policy. You want this block to be coming from your, say, network, AS17821, right? So you create a route object telling everyone that this is what my policy looks like. Okay, I have this block. It should only be announced by this AS number. You do that by creating a route or a Route 6 object. Okay, the two important fields here are, of course, your Route 6 and your origin AS number. Next one, OTNUM object. What is this? OTNUM object, very simple, is an information about your AS. Here you have AS17821, okay, some description, and we gave it a name. And look at this. You have an import and export statement. You don't actually see them, these two fields, in all the other objects. Import, export. Remember your policy? If you have, say, a neighbor, if you have a peer, okay, and through some, say, negotiations or, talks with them, okay, you both agree that you will only, say, send traffic to their side that is originating from your network, not from all of your other peers. Okay? You specify that by creating, okay, this. This import and export statement actually is an example of RPSL, Routing Policy Specification Language. Okay? So what do I say here? This is my network, AS17821. I have a neighbor. What AS is my neighbor? AS4608. And then, for my policy, import policy, I accept everything that's coming from my neighbor. My export policy is I'm only announcing my own prefix, okay, going to that neighbor. Can anyone explain to me what this means? Okay? When it comes to traffic, what types of traffic will go to AS17821 coming from AS4608? From any AS, coming from any AS, I'm accepting all traffic from AS4608. Everyone agrees? Everyone agrees? How did you say that? Because of which statement? The import or the export statement? The import statement. Okay, just going back to basics a little bit. Here, talking about announcing your prefix. When you announce a prefix, what does that mean? You get traffic. Is that right? You announce your block so that other networks will get to your network. Sorry, your traffic will come into your network. You're telling everybody, hey, this is my address. Okay? This is my address. Please come to me. So, actually, you were right, but that is because of your, basically, your export statement. Okay, you're just giving them your, so all traffic will go via that AS4608. Is this clear with everyone? I have some more examples, okay, don't worry. That's just one, okay? We will get to more complicated stuff in a little while. Hopefully we have time. But some more objects, AS set. So if you have an OTNUM object and you have a group of these autonomous system numbers and you want to group them together because maybe for some reason they have shared properties. Okay, you want to implement them into this network. You have a policy that corresponds to all of those networks. Then you can create an AS set. The naming convention is like this: AS dash and then whatever, say maybe your company name, etc. If it's non-hierarchical. However, if it's hierarchical, meaning maybe from that AS, you have different customers or different peers, you name it like this: origin AS number, say AS 17821, colon, AS dash, say customer or AS dash peers. Okay? Example is like this. So far, for this AS set, I've only added one member, AS 17821, but I can add more. Okay, they will all belong to this AS set, and if I want to implement this, okay, say particular, say RPSL for all of those things, I can easily just add more AS numbers onto this AS set and reference the AS set rather than individual ASNs. Okay, that's your AS set. Another one is route set. Again, similar to AS set, it's a collection of different route or route 6 objects. So normally, you just add an RS at the beginning to specify that's a route set object. Or you can also have this format: AS number, colon, RS, dash your organization. Say AS 17821, colon, RS, dash APNIC training. Okay? That's my example there. It's very simple. RS dash APNIC training. I guess the important part is this: MP members. Can specify an AS number. I can specify an IP address. Now this IP address, notice in the previous example we're using members, and we only add either AS or an IPv4 address. If there's an MP at the beginning, okay, it's kind of like meaning you can use both for IPv4 and IPv6. So if you're referring to IPv6 addresses, you normally use the attribute MP-members. Okay? Another one is filter set object. Anything that has the FLTR dash at the beginning. An example is this. It's a very good example. Filter dash Martian dash V6. You can actually create an object. Say in this example, what are we trying to do? We're trying to filter out all prefixes that are Martians. Prefixes that should not be announced, that you should not receive because they're either reserved by the IETF or used for special purposes. So there's these blocks, right? 0100 colon colon /8, 0200, all of these. Okay, they're reserved for particular purpose, and so you should not receive any prefix with this, coming from these blocks, from these ranges, right? So you can reference this filter set object on your, okay, in your import or export statements. I'll show you an example just a little while. By the way, this object is actually maintained manually. Okay, so you can create your own one. Okay, there are, this one is created based on RIPE NCC. Someone there is actually maintaining it and updating it every once in a while. So you can reference to those objects because they're public, or you can create your own filter set object. So what are the objects that we have created so far? We have the ones that are important to just IRR, I guess, would be route set, AS set object, okay, filter set objects. For those of you who are quite familiar with WHOIS objects or WHOIS database, these ones may be kind of new. We normally create person, role objects, autonum, iatnum objects, but possibly not these types of objects. So some familiarity would be good. I showed you an example here. Now you can go ahead and create your own, depending, of course, on your policies. So as I've said, these objects are linked together. They are referenced from one object to the other. An example is if you have an inetnum object here. In the inetnum object, you will have information about the maintainer. So if you click on this link, actually, if you look this up using the web, the APNIC WHOIS database on the website, then you come up with entries with references to other objects. You can easily click on that so that it will give you information about the maintainer and the person object. Okay? So person objects, maintainer objects are usually referenced in the resource objects. Now what about all the other IRR objects that we have discussed? It's like this. So you're familiar with this part. Should be. You have an inetnum object. Okay, you have person or role objects reference using the technical TechC or admin C context. So reference to that. And you have a main by, main routes, main lower. So you reference to the maintainer. Now you have here as well a route object. This route object should point back into your inetnum object. Remember, okay, you can only create routes for objects with the main routes that are the same in your route object and your inet or inet6 num objects. Okay, another one is your auth_num object. Here you have your same thing. From this auth_num object, you can reference to that in your route object. You're saying that for this route, it should be announced by this AS. And that AS is described by your auth_num object. Okay? Another one. Okay? Same thing really, but just to show the linkages between different, say, sets of objects. If you have multiple, say, route objects, this route and this route, you can create a route set object that has these 2/20 blocks as the members. Same thing with AS set. If I have multiple autonomous system numbers, auth_num objects, okay, I can create an AS set object with members pointing to AS10, AS11, and AS2. Okay? Questions? Yes, sir. Going back? It is entered through the WHOIS database. Yes, if you're, it's basically on the IRR, Internet Routing Registry. So you can choose which IRR you would go for. Generally, it's well recommended to update it using the WHOIS database. So yes, for us here, if you're APNIC members, you update it on the APNIC WHOIS database.
So, is there any self-check when it is something which is not correct? For example, there is any warning or?
Well, if you do this via My APNIC, then there are some checks. For example, when you start filling up the form, you add an object or you update an object, it will give you some drop-down information that this is kind of like autocomplete, that this is the block that's assigned for this network. That is if you do it via the APNIC portal. If you submit it, say, to APNIC help desk or host masters, then they will do the checking manually for you. Yes. That's kind of reassuring, but obviously, by adding information on your import-export statements, that's up to you. Okay, you provide that information. Okay, there might be some checks, but obviously, you're supposed to be the experts on your own network, which one's your peers and not. So that's on your own.
So I was thinking that maybe some there's some ability, like a coding program, for example.
Mm-hmm.
It will show you when you type any wrong.
The question is, how do you know which one is wrong or not? How could the system actually know that?
Because when you input the information, when you based on the trial and error, check that
Yeah. There are some tool sets that I will shortly go through, but it's based on the information that we have on the IRR. So I guess the IRR, you should really be very careful with the information that you put there, especially your import and export statements, or RPSL, I would say, because generating the code or the configuration will be based on that, and you have tools to create those configurations. But for the objects, creating objects, it's largely will be up to you. There are some guidelines on how this can be done, and some help, of course, from some staff, but generally, it's your routing policy at the end. Okay, any other questions, sir? No? We can continue. So RPSL objects, now we've already discussed and mentioned IRR to you a number of times. I guess the important thing for this slide is to know that there are many public databases out there. I do get a lot of questions when, every now and then, but so what's RADB? What's your difference with RADB? Because RADB is one of the most popular routing registries, private routing registries out there. So if you go to irr.net, it gives you a list of all the public databases and which other registries they are mirroring. For example, most of the private or non-RIR databases, they are mirroring all of the RIR databases. Okay? So if you create an object in APNIC, okay, this will be mirrored most likely to others such as RADB. Okay? But some cases it's not true the other way around. So for example, I change an object in, let's use the same one, RADB. Okay? But it's not mirroring back to the APNIC database. So when you check both of these databases, the information are not consistent. So just make sure, okay, just double check. I guess you can use this website as a reference and check which databases are mirrored by that particular RIR if you chose to go with that IRR. Okay? Okay, let's just skip that. Yes, sir. Mm-hmm. If you don't have, yeah. Well, it depends. You have to choose which database you're using. And if you choose to go with RADB, you should probably should have an account there. But as an option for you, if you get your prefix from, say, APNIC, you can easily just access your My APNIC account and create your objects from there, and it should be mirrored to all of those different public databases. So as an APNIC member, I think the best way for you, okay, I'm not being biased there, but I think the best way is for you to just create your objects from the APNIC database. Does that make sense? That's clear enough? Mm-hmm. Mm-hmm. RADB is just one of the IRRs. So it's just a matter of you choosing which IRR you want to go with and update. Okay, so whether you're multi-homing or not, you should, or what you want to create different objects for different routes, different, say, origin and stuff like that, you should be able to do that regardless of what type of database you're using. Yeah. APNIC, using the APNIC quiz database, you can create that same thing. Small ISP? Well, if you do have, say, a block, and if you're an APNIC member, and then you have access to the portal, yes, you can update that. But if, say, you're a small ISP that gets their IP address block from, say, an upstream provider, then they will have to leave it with the upstream providers. Mm-hmm. Yep. Sorry, I don't get your question. If you have from different... Mm-hmm. APNIC maintains an internet routing registry, yes. It's part of the APNIC database. And your block happens to fall in the, say, APNIC region, so it will go into the APNIC database. It will be mirrored by all the other IRRs out there. So, but yeah, as I've said, you might want to check with the listing if it is mirrored to which particular IRRs, because it's not always mandatorily given to everyone. Depends. Yes. Yes. Yep. So it's a matter of choice. Some people would just go and update their RADBs, but if others are referring to the RIRs more, then if it's inconsistent, then we'll have to do something about it. Yeah, because everything that you update in, say, RADB, I don't think they are mirrored back to APNIC. That's kind of like an issue. Yeah. Any others? Okay. Now, how to check for those objects? Use the whois. Two options. Use command line. There's a whois utility. Or go to the APNIC website. Somewhere up on the main page, you'll see a link to the whois search. And you can easily use that. Some of the objects that you can query, basically everything. And these are some of the flags that you can use. Whois -h just refers to which whois database you want to check. Do you want to check the whois of, let's say, APNIC, or RIPE, or BGPMon, or any others? Okay, you're specifying the host. -I is inverse. This is useful if I want to see all of the objects that, say, maintained by this maintainer, main AU APNIC training. Then you can use the -I. Okay, I think this one should be, yeah, it's a -I, that's also -Q. We also have a -K for primary keys. So there are many options. Okay, it's just a matter of going through like what information you want to get, and then using these options for your case to give you as much or as little information as you want. How many of you have used the whois utility here? Okay, we might have some examples later. Okay, now how do you implement this whole thing? How do you begin? Where do you begin? So I have some things here. First one, you need to identify which routing registry you would use. I think that's the discussion that I had with one of the participants just now. You have to decide for yourselves, do you want to run your own? Do you want to refer to the RIR's database? Do you want to refer to another one, like say a public database such as RADB or others? Next, you have to then decide what degree of filtering is used for your network or you want to implement your network. You can do that by creating, say, your prefix filters, your AS filters, creating your route objects, your import-export statements, or maybe you can do both. The last one there is to register a maintainer object at your chosen IRR, and then manually update and complete that process. That's just the beginning. And then what's next after that? These are the steps, okay? Think of it as your checklist. 1, define your routing policy, okay? Create the objects in the IRR, and then use automated tools to generate the configuration. Let's start with maybe the first two. Okay, you already have, most likely you already have your routing policies, and you put that into effect by creating the objects. Which objects? Route objects, autonum objects, route set, filter set, AS set objects. Example, these are the objects that most likely we will be creating. Okay, that will be any autonum object with a corresponding import and export statements. Okay, so the import and export attributes are very useful and very important in this case. Again, I've described this earlier. Okay, route announcement is the opposite of traffic direction. Keep that in mind, because when you announce, it has an effect on incoming traffic. Whatever you, say, accept from others, that's import, it has an impact on what goes out. It's always on the opposite direction. Okay? Another one. I think this one is an example. So I have this is me, AS17821. Okay? On the very basic, what do you think should my autonum object look like? I have different peers, right? If you notice from this diagram, I have my upstream provider, AS4608 is my transit. I have peering with AS65543, and I have a customer, AS131107. Let's look at each one of them. What will be my import and export statement? Let's say, for example, this and the upstream, AS4608. What do I want to happen with my traffic here? I accept everything coming from my upstream, right? That's my only upstream. I accept everything, right? I get all traffic, and I only announce what? My prefix. And since I have a customer, I also need to forward that. So what my import statement will look like is this. From AS4608, I get everything. I accept anything, which means I'm forwarding all traffic to that upstream. I have information of all the other networks out there so that I can forward traffic going out. Next, export statement. To AS4608, announce my AS number and my customer's AS number. Only those two. Why?
Anyone else from the world can connect to you via 4608.
Yes, exactly. So everything goes via 4608, but must reach your network and your customer's network. Very good. Is that clear enough? Next, how about for this peer? What do I get from that peer? Well, depending on what you agreed, okay, with the peering, most likely you will only give information about your network and your customers. So import, from AS65543, accept only this AS65543. Okay, export, I only give him my AS17821, and my customer, AS131107. And you can see that here. Okay, I'm announcing two AS. How about for this downstream? I also have peering there, right? Okay, it's also BGP there. Import, what? From AS131107, accept only AS131107. And export to AS131107, announce everything so that he can go to any network on the internet through AS17821. Clear enough? Okay? If you're confused, you have to tell me, because I have more complex examples coming up. This one is a very good example. Autonome object. Notice we're using MP import and MP export. And if you look at this import and export statements from the previous slide, it's kind of different. You have your AFI IPv6.unicast. So you always add this if it's MP import and export, meaning this is for v6. So AFI IPv6.export, IPv6.unicast, and then the others are kind of the same. From this network, accept your policy. Okay? Or for export to going to that network, announce this. So everything else from here, I would say, are the same as the previous slides, but you always have this. Just don't forget that. It's a little bit different. That's based on RFC 4012 or RPSLNG, basically to allow v6 addresses there too. We use regular expressions a lot when creating filters. So familiarity on this will be very useful for you. Things like this. If you have a star there, what does that mean? AS17821, you have 0 or more occurrences. If it's a plus, it's 1 or more. If it's a question mark, it's either 0 or nothing, 0 or 1, right? And a few others, it can be beginning of a statement or the last. You can create those types of filters. And make sure to always enclose them with the less than and greater than symbol. Examples. I have an example that shows local prefs and prefending, but is anyone familiar with local pref? Okay, very good. So with local pref, I guess you look at this one, the lower the pref, the more preferred the route is. So where do you put that? Example here. So this is for V6 MP import AFI IPv6 unicast from this AS65001. Okay, you disregard this two first. I'll explain that in a while, and then action. Okay, our earlier example is very easy. From this network, accept this. Now this is a little bit more complicated, I would say, because you now have an action field. What are you going to do with that, well, if it meets this requirement, meaning anything coming from this network. So from AS65001, okay, connected to this IP, that's basically the router IP addresses, okay, 10:::2, and then on the other sides, it's 10:::1. And then you have community that append, okay, 178.2.1.650.0.1, so that's the AS numbers of both those networks. And then you have here, the important part for this slide is the pref. Pref here is set to 200. The default is 1,000. So if you have pref 200, that's actually 200 less of 1,000, meaning your local preference is actually 800, not 200. Okay, so that's 1,000 minus the preference value that you have set. Now, instead of using local preference, another way to, basically for export, for outgoing announcements, basically, you can use AS path prepending. And you do that by AS path.prepend, and then you just add the same AS how many times you want. Okay, same concept for AS path prepending. Yes? If you have a local preference of 100, okay, you put this as, this pref is 900 pretty much, yes. Okay, so that's 1,000, or you can have different, like you just base it on 1,000 and then add 100 to the other link. It's up to you. You don't have to go all the way to subtracting them. So you just use the base 1,000 and then you create this default. So maybe you just set to pref 100 for the other. So that's going to be 900, and the other is pref 200. So that's 800. So you still have that kind of like preference between them. Okay, any other questions? MED, everyone's familiar with this. With MED, okay, it's basically for outgoing. So export statement. So you have two networks, AS65001 and 178.21. To AS178.2.1, okay, via this link, which is 10.0.0.4 connected to or at 10.0.0.1, okay, I assign action an MED value of 1,000. Okay, so announce this AS going via this link, giving it MED 1,000. Now via this other link, okay, I assign MED 2,000. Which one do you think will be preferred? 1,000 over 2,000, is that right? With local pref, lower is better. With MED, higher is better. Okay, it's the other way around. You can also set communities. Okay, do we need to go this far? I'm not sure you're familiar with all of these things, so I guess just do a bit of reading. I have the examples. You can refer to the RFCs if this is like a bit more complicated for you, but you can also create things like BGP communities. If you remember this, I have this in the previous slide, community.append. Okay, you can use that in your statement. And where does it go? In your OTNAM object. You have import and export statements there. Now there are tools available. Someone asked this earlier. What are those tools? There's a few out there. I guess the most popular will be the first one, IRR Toolkit. So you can use this, you can install it. It's, I think, open source. And then what you can do is generate the configuration based on the information that you have on your IRR. That's how it is. Just a comparison of different tool set. It's up to you. I guess what you should look at really here, okay, if you're preferring one tool over the other, is if it has support for 32-bit ASN and if it has support for RPSLNG, okay, IPv6 and 32-bit ASNs. So how do you use this? I'll just show you an example. I suppose that's easier. Okay, this is what we created earlier. If you remember, Martians, we have a filter set object for filter Martian IPv4 and for IPv6. You can also use this for your import and export statement. So you accept everything. You accept any except or and not this filter Martian v4 or filter Martian v6. You can do that. We're not officially maintaining any of these objects, but we have created, for training, we have created these objects in the APNIC quiz database. If you want something that is more maintained, RIPE has kind of like a similar object in the RIPE database. Okay? But this one is kind of like mirroring what RIPE has, but I cannot assure you because it's not really official. We use it for training purposes, but you can refer to this and create your own objects. Example, this is how you install this, but I'll just assume that you've already installed this. So you'll have something called rtconfig in your command line, and you do this import and export statements like that. We won't have time to go through everything, so I'll just quickly show you an example. It's basically that, but let's use this one here. Now, I already have installed rtconfig. I'm running Mac, and the way to install this is just brew install, something like brew install, I think rtconfig or IRR toolset, something like that. And once you have that, you can easily do rtconfig minus protocol. The usual protocol that we use is bird, BRD, then minus config. You choose whether you want to create the config for Cisco or Junos. So in this case, maybe let's use Cisco. And then you specify from which database. So minus H, which host, who is .apnic.net. And when I do that, I go to the rtconfig command line, and then I can create my configuration. Maybe I have AS17821, and then I want to look at the import statements for that and create configuration based on that. So I do at rtconfig import AS17821, and then if you remember like which IP addresses were used for the link, this is actually the link from one of our routers going to a customer router. So the IP addresses are 10::1 and 10::2 between AS17821 and AS65001. So you can see it's just like direct connection between them. So I can just do specify those IP addresses automatically here. So 2406.6400:10::1, and then the other is AS65001, and then the IP address 2406.6400:10::2. If I type that all correctly, it should come up with as this. Does this one look familiar? Now we're talking. So this one is quite familiar with most of you. You have, where's the start? You have here, no IPv6 access list. You've created access list there. You've created route maps. You've referred to the ACLs that you've created. And if you look at the objects, that is based on the information that you've added on those OTNAM objects. So what you can do after this is just copy this whole thing into your router. That's it. Okay, if you want something for, say, Juniper, for Junos, I don't think you can do it from here. So you have to do this again with config for Junos. Okay, so once you're there, you do the same command. Okay, that's the only difference. Only when you're running RT-config. So I do this, and that is your configuration. As you know, Ginos and Cisco configuration is a little bit different. So this one is how it looks like with Ginos. Okay, so you can do this. So again, this all depends on the information that you have created prior to this. That's why we spend a lot of time describing those different types of objects and how you can update the IRR based on your own policy. Any questions? Okay. Do we still have time? We do, right? So just a complete picture of IRR and IRL toolset. So automation relies heavily on IRR being complete, meaning all the objects have been created. It's all correct based on your routing policy. Any mistakes, whether it's minor, whether it's intentional or not, okay, whether it's like, say, maybe some configuration from 10 years ago that you have failed to update, it has an impact. Because maybe it's not you, but it's another network that will generate, okay, say this policy that is now added to the routers based on the information on the IR, which is a public database. So be prepared to make manual overrides if needed. So those are the steps that you have. Make sure that you have them. Define your policy, create your objects, run RT-config, generate your config, and then push those configurations onto the routers. Now the problem is, most information in different databases are not consistent. So as an owner of these objects, just double check. Double check the information that you find in RADB, double check the information that you have in the APNIC database or any others that you have and update them as needed. Questions? Do we need to do RPKI? We really don't have time for this, but I'm going to go through just a little bit towards the end. I think most of you are familiar with RPKI, right? You've heard about it. Basically, huh?
When will be able to check the path?
Check the path, not yet.
Can you give us an outline?
I don't know. There's still a lot of discussion happening in RATF with regards to path validation. I don't think we will have it very soon. Yes. So we pushed as a standard, but for now, it's origin validation. Okay, that's like half of the whole thing that we wanted. We want both origin validation, where we're sure that this prefix is announced by this network. Okay, the objects IRR kind of like helps in that sense. You can check that based on if it's updated. You can check based on the route object that this prefix should be announced by this origin, right? But for path validation, sorry to say, okay, that's the second phase. Phase 2, we're still waiting for that. What does path validation means? You're now checking this part, okay? Not just the origin, but like how can we actually get there? These AS path, okay, we will be looking at that. There are cases like where your traffic should just be hopping 2 or 3 networks to get to the destination, but maybe it's going all the way around 10 different hops, but still going to the same destination. But it's taking the longer route, which is kind of like questionable. So I guess with path validation, that's what you were checking. Components and how you can build this. So building blocks, you have trust anchors, ROA, and validators. So what you can do for now is using the RPKI chain of trust, okay, create your ROAs. What's chain of trust really? So you're familiar with public key infrastructure and how trust is done with PKI. It somehow takes some concept with that, but instead of using things like or places like CAs, we now have or will be using the, say, trust hierarchy of the regional internet registries, so RIRs. That's where you get your prefixes, so you validate or you create your objects, kind of like your certificate, so to speak, using those as your parent objects. Okay? ROAs and origin validation is basically your routers should have support for RPKI to be able to do this kind of validation. So the first step for you, okay, is to create your objects. Then we can, or anyone can, validate whether you have either valid, invalid, or unknown state. When you say valid, an entry has been found, and it actually points back to, let's say, correct, basically the stuff that you put there. Correct origin, correct AS, and this IP address block, and the prefix. So I have announced 2406-6400/32 from AS17821. Okay, I've created the row object for that. It will be added onto, say, some repositories, and then your router can do validation. Your router can check, oh, I have this prefix on my routing table. Okay, is it actually coming from this AS? Is this actually originating from this AS number? If it's correct, then it's valid. I've checked it with a database. If it's not, maybe in my routing table, it's originated by AS 17820. Not 17821. Okay, so it will come up as invalid. Okay, unknown, most of the times you'll see this because not everyone has created their row objects yet. Okay, but if we do, then probably we'll have just these two. So what can you do? One is, okay, this is an example of these different row states. You can check validation and say different, let me just see an example. I have a validator. Okay, just very quickly, I'll go through the configuration part and stuff like that. So for configuration, first thing that you need to do is create your row objects. If you're an APNIC member, okay, log into My APNIC, enable resource certification there if you want it to be done using the My APNIC RPKI portal. And then from that, it shows you all of your origin AS and prefixes, and you can create objects from there. You just need to specify your origin ASN, the prefix, and maximum length. Okay? Yes, sir. So one will help you. It's not blacked out. It depends on your, if you're allowed to use it or not. Usually it's either you're using two-factor authentication or you have a certificate. If not, then it probably will not show you because it... Okay. Let's have a look at your situation in a while, okay? So one over there, have a look behind you. He'll be able to help you out. But yes, you have to create your row like this. This is an example. So what does it say? I have this prefix, should be originated by this AS17821. As simple as that. We're just certifying this, creating a verifiable object so that if once it's announced, we can refer back into that repository and we're sure we have verified that, oh yes, it's true that it should actually be originated from that AS number. That's pretty much it. Okay, it's verification over, yeah, kind of like authentication or something like that. How do you check this? You can also use the Whois database. So Whois -H, BGP1 has got this kind of like setup where it shows you the origin AS and the RPKI status. So once you've created your row record, you can actually use this. Tells you whether validation is successful or not. That's just one. Another is you can use the RPKI validator. Okay, there are some that are already available, I think, online. But you can install the program itself on your own network, on your own routers. Sorry, not routers, on your own servers. Okay, and then run that validator. I have one here. You can actually refer to it if you don't know where to look at. Okay. So this is an example RPKI validator that we have set up in our lab. So what can you see there? A lot of information. If you're just on the main page, some quick overview on how you can create your objects and create filters based on that. If you click on this link, it shows you all of the trust anchors from where we're doing the verification. Here you see APNIC, AFRINIC, LACNIC, and RIPE-NCC. Okay, so meaning each of them have their own repositories, and I am, this is like basically getting all the information for VRPs or validated ROA payloads from these repositories. Now, I guess for you, what you can look at is either this, validated ROAs. You can do a search on this side. You can type in, say, your prefix, just to double check, okay, if it's a validated ROA. Or you can also use this link, BGP preview. From here, it's actually a bit more visual because it gives you ASN, prefix, and information on the right side on its validity or not. So it will show as valid, invalid, or unknown. So for example, if I have 2406, 6400, well, I don't have information there. It's not added. Okay, just use a more generic one. So I have a lot of prefixes here. Some of them are unknown, some of them are valid, if you notice that one. Okay. Obviously, there's still a lot of unknowns, but you might chance upon some invalid ones as well. Yep. These ones are all valid, which means, oopsie. Okay, sorry, I can't get back to it anymore. But yeah, you can refer to this. There's a few others that you can find that kind of like implements the same thing, or you can have your own. So that's one. These are the router configurations that you can do. You can get a copy of this, so you can use this as a reference when you're creating your own. This part is how you can refer to a particular RPKI server. Okay, it's only a few lines with iOS, and with Junos, you just need to specify the IP address of your RPKI server, the port, and the refresh rate. Okay, more this. This one is creating policy. Based on the information that you get, what are you going to do with it? If it's valid, do you just accept it? If it's invalid, do you drop it? If it's unknown, what do you do? So it's now up to you. You've been given the information. You create your policy from there. In this example, we've set local preference. So for valid routes, we set local preference to 110. We set it to 90 if it's invalid. Set it to 100 if it's not found. Meaning we're giving more preference to valid route over invalid and unknown routes. But we're not totally dropping it. I don't think that's a good idea to do at the moment, unless you're doing some research. Okay? But here you can give priority to some valid prefixes. Next thing that you need to do after creating those policies is you have to push it to your BGP neighbors. These are the commands. Very easy. So neighbor, IP address of your neighbor, create a route map, route validation in. For Junos, set protocols BGP import, route validation. As simple as that. Okay? Those are verification things that you can have a look once you have set up. Okay, show IP, BGP, and your prefix. It will tell you, okay, the status, if it's valid or not. Okay, those are all of the commands that you can refer to. Caution, don't do this on a live or production server. This is a sample one of my colleagues did. He tried to some of the commands on his, I think, a Juniper router. See that command, show IP, BGP, RPKI servers, and then after a while, boom, crash. So test it on a non-production server. I think that's just like a lesson for us, all of us to learn from here. And that's pretty much it. There are some test beds out there that you can try. You don't really have to do it by yourselves. If your, say, infrastructure doesn't support it yet, you don't have a router that can do it, easy. You can use this. Okay, both of these are up. I've just tried this, I think, yesterday. It doesn't have a password. You can log into the router. You can play around with it, do show commands, look at all the valid prefixes and all. I think it has the full routes. So, yeah, it's a good thing to have a look for yourselves. Okay, so I think we should end there. It's 10:40. Okay, some reference links there. And make sure to create your row records. Again, that's in MyAPNIC. Log into your MyAPNIC accounts and create your rower objects. That's the end of the session. Thank you very much for joining. If you have any further questions, please approach us at any time. Thank you.